Welcome to Easy Elim Learning Simplified. My name is Ruth, and the topic for today is chemical families. We are going to be looking at the noble gases. Previously, we were able to look at the halogens and also physical and chemical properties of halogens. So for today, we're just going to cover the whole of noble gases. We look at some of the elements that are in the group, and then some of the properties and uses of noble gases, and then we'll end the lesson. So noble gases are elements with the maximum possible of valence electrons. So they usually call them group 8 because most of them have 8 electrons in the outermost shell. They're usually gaseous in nature and they are monoatomic gases. So there are gases made up of one atom. Members of this family are helium, neon, argon, krypton, xenon, and radon. And they usually occur as free atoms in nature, so they do not combine since they are unreactive. We are also going to talk about the unreactive bit of it, although later on there are some members that were thought to also react. So those the elements and their configuration you're going to pay our attention to are these three because the rest are below the 20 element. So you can see helium has two electrons in the outermost shell. So we say it has a duplet configuration, and then neon has 2.8, argon 2.8 and 8. So these ones have octet configuration. So that's the reason why we talk about the duplex and octet. So you can see where they're located in the periodic table. They're in group 8 at the end. So we have helium, neon, argon, krypton, xenon, radon, and also we have other elements in the transitional elements as well, biode. And then when you look at some of the physical properties of noble gases, one of them is the radiuses, the atomic radius and ionic radius. So remember we said the atomic radius is the distance between the center of the nucleus and the outermost energy level of an atom. And then an ionic radius is the distance between the nucleus of an ion and the outermost energy level occupied by electrons. When you look at the trend of the atomic radius, it increases down the group. The reason why it increases down the group because there's an increase in the number of energy levels down the group. So you saw from the previous slide that we have an extra energy level as you go down the group of group 8. And then next we look at ionization energies. We said ionization is the minimum energy required to remove an electron from the outermost shell of an atom in gaseous state. So you can imagine losing an ion or an electron, not an ion, an electron in the outermost shell of a full shell. It's not going to be that easy. So noble gases usually have very high ionization energy and they're usually monoatomic gases with a duplet and an octet configuration. The nuclear attraction holding the electrons together are usually very strong. That is the reason why they have high ionization energies. But as you go down the group, since the atomic radius is becoming bigger and bigger and bigger, it means the electrons in the outermost shell are being held loosely by the nucleus. So that is the reason why it is easier to remove an electron as you go down the group, and that's why the ionization energy decreases. So as the size of the atom increases down the group, this is due to the increase in number of energy levels. The force with which the electrons in the outermost energy level are attracted towards the nucleus decreases. Hence, it's easier to lose electrons as you go down the group. So we're going to see an exception in this group. We say that this group has a full shell. So their tendencies to lose electrons are so limited, but we do have an exception that we're going to mention in a few. So next we look at some of the properties is melting point. usually have generally very low melting point because they are molecular in nature. We said they are monoatomic gases and they are molecular. They have weak van der Waals forces that are very easy to break. These forces are in between the molecules. So that is the reason why their melting point and boiling point are very low. And when you look at the trend, the melting point and boiling point increases down the group because in the same reason we talked about the melting point and boiling point increasing down the group of halogens, we talked about the increase in the size of the molecule affecting the strength of the van der Waals forces. So the bigger the molecule, the stronger the van der Waals forces. So that is the reason why as you go down the group, you require more energy to break the strong van der Waals forces. They are strong because they are strong to hold the large size of the molecule. Next, some of the chemical properties of noble gases. So we said noble gases do not lose or gain electrons, they are stable. So they're unreactive. That is the reason why they rarely form any ions. So that's why they do not take part in most of the chemical reactions. However, we have an exception with xenon and radon because they have a very large atomic radius. They usually take in some reactions, especially when they react with very high electronegative ions like fluorine. So xenon is one of the exceptions. We say this because it has a large atomic radius. So the outermost electron is not attracted. It is very far from the positive nucleus. So it is weakly attracted by the nucleus. So it has very low ionization energy compared to other gases. So that is the reason why xenon usually take part in some reaction. So this is the reason why we no longer call the noble gases rare gases or inert. We don't call them inert gases, not rare. They are not called inert gases because xenon can actually take part in some reaction, and mostly with the strong electronegative fluorine ion. So some of the uses of noble gases, just like we said before, when you're asked to state the uses, make sure you state for specific noble gases. So argon is usually used to light bulbs. It provides an inert environment that prevents oxidation. It is used as an insulator as well in arch welding. And then neon is used in street and advertisement lights. Helium is mixed with oxygen and used in deep sea diving and mountaineering. We mentioned this when we were stating the uses of oxygen in the Form 1 videos. Helium also, when you mix it in with oxygen, it is used in hospitals for breathing patients who have breathing issues. It can be used instead of hydrogen in balloons for meteorological research. We said hydrogen is one of the lightest elements, but it is very explosive in air. So it causes some serious accidents. Um, so that's the reason why helium is used as an alternative. And also helium is less dense than actually iron. It's actually lighter than hydrogen. Helium is used in thermometers for measurement of very low temperatures. And finally, it is used to keep some metal alloys at temperatures low enough for them to be superconductors. So that brings us to the end. So noble gases do not have like so many properties as we noticed with other chemical families in halogens, in alkali metals, and alkaline earth metals because we said they have an unreactive nature. Of course, we have the exceptions. That's the reason why we don't have so many properties. So I hope you have been able to see the little physical properties you have noticed with with noble gases, and also the uses, especially the uses, because you can be told to mention maybe 2 or 3 uses of halogens. Make sure that you're able to do so that comfortably. Otherwise, see you in the next lesson as we start a whole new topic. See you.